This video is presented to you by www.testprepadda.com. Dear students, in this video lecture, we will learn about acceleration. As we did in the previous lectures of kinematics, we talked about average and instantaneous. Here also, we will talk about average acceleration and instantaneous acceleration. If the velocity of a particle does not change with time, then we say particle is moving with uniform velocity. But if the velocity of a particle changes with time, we say it is under acceleration, or we say it is accelerated. Please note, I am not using word speed here. I am using velocity. So here direction is very important. Now, how will you define acceleration? Acceleration is rate of change of velocity. For example, if I say the velocity vector of particle at time t1 is v1 vector, and velocity vector of particle at time t2 is v2 vector. Then what is the change in velocity? Change in velocity will be written as v2 vector minus v1 vector. This is change in velocity. And what is the time interval? Time interval will be written as t2 minus t1. So what will be rate of change of velocity for this time interval t2 minus t1? The rate of change of velocity will be v2 minus v1 upon t2 minus t1. Change in velocity upon time interval. This is known as average acceleration. Average acceleration. Got the idea? So in a time interval, when we find the rate of change of velocity, that is called average acceleration. Here also, path of the motion does not matter. Velocities at t1 and t2 are required to get average acceleration. Got the idea? Now we will talk about instantaneous acceleration. As we did in finding the instantaneous velocity, here also to find instantaneous acceleration, we will take the time interval delta t tends to 0. We have written average acceleration as delta v upon delta t. So for instantaneous acceleration, we will do this. Delta t tends to 0. Then average acceleration will become instantaneous acceleration. Instantaneous acceleration. And that will be written as limit delta t tends to 0, delta v by delta t, which we write as dv by dt. Got the idea? This dt indicates that it is differential time interval. Now it is the rate at which velocity of a particle is changing at a particular instant. Got the idea? At a particular instant. This instantaneous acceleration is also called acceleration. So when we say or when we use word acceleration, it is actually used for instantaneous acceleration. Now another important point. Dear students, please note that the velocity is a vector quantity, and hence whether magnitude of velocity changes or direction of velocity changes or both, in all these cases we say particle is under acceleration. For example, if I take a circular motion, even if magnitude of velocity, that is speed, remains same throughout the motion, but you can see during the motion the direction is changing. That is why velocity changes, and since there is a change in the velocity, we say particle is under acceleration. So it is not important every time that the magnitude changes. If the direction changes, then also we will say particle is under acceleration. Since we have written acceleration as dv by dt, so if we draw a graph between velocity and time, so the graph, for example, this, then at a particular instant of time, if you find this is the slope. So dv by dt actually represents slope of the path given. Got the idea? Now, what is the unit of acceleration? You can see dv by dt, v by t, the unit of velocity is meter per second, time is second. That is why unit of acceleration will become meter per second square. And the dimension here you can write easily. The dimension will be lt minus 2. Okay? Dear students, please note that if the signs of velocity and acceleration, very important, if the signs of velocity and acceleration of a particle, or you say direction, are same, then the speed of the particle increases. But if the signs or directions are opposite, the speed of the particle decreases with time. And in that case, we say particle is under negative acceleration. So the meaning of negative acceleration is that acceleration is in the opposite direction of velocity, or you say velocity and acceleration are having opposite signs. This negative acceleration is also written as deceleration. Got the idea? Now, if the position vector of a particle in a given frame of reference, consider this, is written as r is equal to x I cap plus y j cap plus z k cap. Then if we break the motion of particle into three components, or better three straight line motions, then dx by dt, this dx by dt represents the velocity in the x direction. And if we differentiate this, that means dvx by dt, this represents what? Acceleration. Acceleration in the x direction. And since velocity is dx by dt, then if we write here, then it becomes d square by dt square of x. Got the idea? So we can write directly this acceleration in terms of x. Now similarly dy by dt will be written as vy, and dvy by dt will be written as acceleration in y direction. So if I consider this as ax, ay I can write as d square y by dt square, and az I can write as d square z by dt square. So the acceleration will become what? Del square x by dt square I cap plus d square y by dt square j cap plus del square z by dt square k cap. So this way we get acceleration. Now to understand the concept of acceleration, I'll take a question here. Here the question says, a particle's position of x-axis is given by x is equal to 4 minus 27t plus t cube with x in meters and t in seconds. The first part of the question says, find the particle's velocity and acceleration as a function of time. The second part of the question says, is there ever a time when velocity becomes zero? Dear students, please note here it is one-dimensional motion, that is in the x direction. So we can write here Vx is equal to dx by dt. This is plus x, this is minus x. Vx is dx by dt. So if we differentiate the given x, then Vx can be written as minus 27 plus 3t square. And we have already discussed acceleration is what? We have to differentiate this velocity, and this way the acceleration comes as 6t. Got the idea? So we have got velocity and acceleration as a function of time here. Now the second part, we have to put velocity as 0. If I write v is equal to 0, I will get time here t square is equal to 9, or better you say t is equal to plus minus 3. So what can we say here? We can say that velocity is 0 both times, 3 seconds before and 3 seconds after when clock reads 0. Got the idea? Now read the two statements. The velocity of a particle is towards east at a particular instant. Its acceleration is neither towards east nor towards west, neither towards north nor towards south. Do you have an example of this type of motion? Mail me at teacher@testprepadda.com. Second statement. Two particles P and Q are moving along x-axis. The particle P has an acceleration a for the first half of the total time and 2a for the second half. The particle has an acceleration 2a for the first half and a for second half. Which particle has covered larger distance, P or Q? Mail me your answer at teacher@testprepadda.com. Dear students, in the next video lecture, I'll talk about one-dimensional motion under uniform acceleration. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.